Okay, well, let's just think about this for a second. Every single moment online, you're streaming something, someone else is making a payment, your smartwatch is sending data. It's an almost unimaginable number of things happening all at once.
It's pure digital chaos. And honestly, if you needed a person to manually manage every single piece of that, the internet just wouldn't work. It would have collapsed a long time ago.
And that gets us to our topic today, orchestration. It's this sort of invisible plan, or maybe a manager, that keeps everything running.
Yeah, think of it like a conductor of a huge orchestra.
That's a perfect analogy. You have thousands of musicians, or in this case, software components, and the conductor makes sure they all play their part at the exact right time.
But it's more than that. It's a conductor that never sleeps and one that can, instantly tell if one of the servers is out of tune and just fixes it.
Right. And for you, the person actually using the app or website, this all leads to two things: speed and reliability. Your apps feel fast, and they just don't crash.
Because the system is healing itself in the background. It frees up human engineers to build cool new stuff instead of just, putting out fires all day.
So let's start with a really important distinction, because I hear people mix these terms up all the time. Automation versus orchestration.
Yeah, they're not the same thing. Automation is really about a single repeatable task.
So like programming one robot arm in a factory to move one box from point A to point B.
Exactly. It does that one job perfectly, but it has no idea what's happening in the rest of the factory.
But orchestration, that's the big picture. It's the manager telling 50 different robots where to move all the boxes, making sure they don't crash, routing them around a mess on the floor.
Right. It handles many tasks and a ton of if this, then that logic all at once. And these systems run 24 hours a day following these pre-written instructions. The efficiency is just staggering.
And it cuts down on human mistakes, which are what, the number one reason systems go down?
Historically, yes, by a long shot.
Okay, so a huge part of modern orchestration is managing something called containers.
Right.
Can you break that down? What is a container?
Think of it as a tiny digital box. Inside that box, you put your software program and every single thing it needs to run all the files, all the tools, it's all bundled up.
So it's completely self-contained.
Exactly. And that's the key. Because it has everything it needs inside it, that container will run the exact same way on a laptop as it does on a giant cloud server on the other side of the world.
And the orchestrator's job isn't just to run the container, it's to make sure it keeps running, right? This is about fault tolerance.
Yes. The orchestrator watches over thousands of these containers. And if one of them just stops working, maybe it crashes for some reason, the system sees that instantly.
And what does it do?
It starts a brand new healthy one immediately. We're talking recovery in less than a second. It's why your favorite website always seems to be working, even if parts of it are technically failing and being replaced constantly.
And it's also smart about where it puts these containers to save power and balance the workload.
Oh, for sure. It's like a logistics manager. It looks for the servers that aren't very busy and places new containers there. It keeps any single computer from getting overwhelmed, which prevents the whole system from slowing down.
Okay, so the software is packaged up and running.
Yeah.
But how do these different pieces of software talk to each other? In a big cloud system, the addresses for servers are always changing.
Yeah, that's a huge problem to solve. And the solution is called service discovery. It's basically a giant, constantly updating phone book for all the software.
So instead of a program having a permanent hard-coded address for another program,
Which would break the second that other program moves.
you just ask the directory, hey, where's the payment service right now?
Precisely. It asks for the service by name, and the directory gives it the current correct address. It makes the whole system so much more resilient.
Okay, so they can find each other? What about the journey the data takes between them? That's network coordination.
Right. The orchestrator sets up all the digital roads and, really importantly, all the security walls. It assigns the addresses and makes sure that only the right traffic can get through.
I like the GPS analogy for this.
Yeah.
If a network path gets blocked, say, there's a huge traffic jam because a new video game just launched,
The orchestrator sees that congestion immediately.
and just finds a new route. You make sure all the little packets of data get where they're going in the right order so your experience stays fast and stable.
Exactly. But it's not just managing the network, it's also managing the computers themselves. They have limits, They only have so much memory, so much processing power.
Resource allocation. So how does it decide who gets what? It's a competition for power.
It acts like a very fair but very strict teacher. It's always monitoring how much processing power and memory each program is using. Then it prioritizes.
So something super important like processing a credit card payment gets top priority.
Absolutely. It gets guaranteed resources. But if some other program starts getting too greedy and trying to use up all the power,
It gets throttled.
yep, the orchestrator put the cap on it. It prevents one malfunctioning app from taking down the entire system for everyone else.
That flexibility is key, especially when you think about sudden changes in demand. This gets us to scaling, which is probably the most incredible part of all this.
It really is. I mean, think about a huge online sales event or the last few minutes of the Super Bowl. Millions of people hit a service at the exact same moment.
The system has to grow instantly.
And it does. The orchestrator automatically adds more virtual servers to handle that massive surge in traffic.
And then, this is a really cool part, when everyone leaves, late at night, when traffic dies down,
It automatically removes those extra servers. It shrinks back down.
which saves a ton of money. You're not paying for hardware you aren't using.
It's a total game changer. It means a small startup can have the same kind of power as a giant corporation, but they only pay for it when they actually need it.
And to manage all of that, you need to be watching everything, all the time. Health monitoring.
Constantly. The system is always sending out these little signals like a heartbeat to check if every piece of software is responding correctly.
And if it's not, if a program is frozen or slow,
The orchestrator knows in milliseconds.
mm-hmm.
A human might not notice for minutes, maybe hours. And it doesn't just send an alert, it takes action.
it'll restart the service, or if that doesn't work, it just moves it to a totally different healthy computer.
Exactly. It's proactive. It even monitors the physical stuff, like the temperature of the servers in the data center, to prevent hardware from overheating and failing.
This all leads to how we get app updates almost every week without anything ever seeming to go down. This is workflow deployment.
Yeah, in the old days, updating software on thousands of servers was this long, risky, manual process.
And now,
Now, orchestration pools can deploy a new version of an app to all those servers in just a few seconds, and they do it safely.
what do you mean by safely?
Well, it does what's called a zero downtime deployment. It starts the new version right next to the old one, slowly sends traffic to it, and only once it's sure the new version works perfectly does it turn the old one off.
What if it finds a bug?
That's the magic undo button, the automatic rollback. If the system sees even a tiny percentage of errors with the new version, it immediately switches everyone back to the old, stable one.
That's why we never notice. It protects the whole system from crashing because of a bad update.
Exactly.
So if orchestration is the central brain, it has to be the head of security too. We're talking about massive amounts of personal data here.
Security is absolutely the top priority. Orchestration enforces really strict rules about who can access what. It builds the digital walls between different parts of the system.
And what about protecting the data itself?
Encryption. Everywhere. It scrambles all the information so that even if someone did manage to intercept it, it would just be unreadable gibberish.
Yeah.
And it's constantly automatically applying the latest security patches to defend against new threats.
There's a great analogy here, the fire door.
Yes. If the system detects any kind of suspicious activity, like a security breach, it can instantly seal off that one part of the network.
It stops the fire from spreading.
Right. It isolates the problem, protecting everyone else's data while the security teams figure out what happened.
Okay, beyond the tech, let's talk about the money. Cost management. Running these huge systems is not cheap.
Not at all. A single server can cost hundreds of dollars a month just to keep running. This is where that dynamic scaling really pays off. The orchestrator is always watching. If a resource isn't being used, it turns it off.
So it's like a real-time financial audit.
Pretty much. It makes sure every dollar you're spending on computing power is actually being used for something valuable. It gives you incredible data on what's efficient and what's just wasting money.
So where does this go from here? This invisible engine is already so smart. What's next?
Well, the next big leap is artificial intelligence. AI is being used to make these systems predictive instead of just reactive.
What do you mean by predictive?
I mean, instead of waiting for a server to fail, the AI will analyze all the data and predict that a server is going to fail in the next 10 minutes.
And it moves the workload before the failure even happens.
Before it ever happens. The problem is solved before you even knew you had a problem.
That's incredible. And I'm also hearing a lot about managing even smaller pieces of code. Serverless functions.
Yep. Instead of a whole container, developers can just upload one tiny function that only runs for a few milliseconds when it's needed. It's hyper efficient. It's the next step in making the internet even faster and cheaper to run.
It really is the invisible engine of our world. It's what lets your games run smoothly and your parents' work apps stay reliable 24/7.
It is the absolute foundation of digital stability.
Keep exploring how the digital world works. See you next time.